Perfect. I'll give it a minute or two just to wait for people to filter in, and then we'll get going. You've got 10 of you at the moment. I'll give it another minute or two, see if we get any more, and then I'll get going regardless. And then people who are a little bit later can just catch up. They won't miss too much. Okay, it seems that 11 people are here. It doesn't seem like any people are joining in a big rush at the moment, so I'm just going to get going. If anyone, like I say, if anyone else joins a little bit later on, then that's also fine. So my name's Sam. I probably should have written that on the first slide. I didn't. I mean, if you forget, I'll reply to most things anyway, so don't worry too much. Yeah, my name's Sam. I'm studying at the University of Birmingham. This isn't an advert for the Uni of Birmingham, but when I explain different things and how different universities do different things, so some of what I say will not be as general as I'd like. I've only come from a certain point of view. So it's just saying that although a lot of computer science courses are similar and they all do really similar stuff, I just wanted to make sure that this says that I'm from the University of Birmingham, so people then know. But this is about why people should study computer science in general, and why I've enjoyed my course. I've taken a 5-year course, the longest one I could, why I'm enjoying it, why I think that other people should get into it. I mean, you're already clearly somewhat interested in it because, I mean, you're attending this webinar here. So throughout, if you want to ask questions throughout, I want this to be as interactive as possible. So feel free to turn your microphone on and ask a question there and then. If you'd rather, you can just put it in the chat. I'll try and keep an eye on the chat or the Q&A. Feel free to put it in there as we go along. And I'll either answer the question as we go along, or I'll say, oh yeah, we'll leave it and get on with it at the very end, and I'll answer some of the questions at the end then. We've got a Q&A at the end anyway. So yeah, like I said, if you've got any questions, either turn your microphone on or just put it in the chat, any one of them. So why do I think you should study computer science? I love the subject. I have done since I was in A-levels. I haven't done any computing before A-levels. I know a lot of you now will be taking computing at your A-level. A lot of you would have done it at GCSE as well. So you'll have a lot more of an idea of computing probably than I did, and most undergraduates actually do when they come into uni anyway. So we'll start by looking at some sort of things and just looking at different kinds of computers and just talking about them. So firstly, like I said, I want this to be as interactive as possible. Can someone, if you like, first, oh, someone's put a question in the chat. Let me open that up. Can you do computer science at uni without doing A-level, but do it at GCSE only? Yes, you absolutely can. I will answer that a bit later on when we get onto that stage, but you absolutely can. Don't worry about that. So firstly, take a look at this. This is clearly a TV. And can some of you tell me perhaps, what is a TV? What does it compute? Is it a computer, and why? I'll give it a second, and if no one's got an answer, that's okay, then I'll just talk through it. Yeah, that's okay, not a problem. So it's a smart TV, this, for the sake of argument, we're going to say it's a smart TV. And a smart TV, it is a computer, of course it is. You can get Netflix on it, right? A lot of them, you can actually go onto the internet and go through the internet browsers. And it's got a computer inside to know, well, how to use Netflix, how to connect to the internet. And even all TVs, like older TVs, your more standard non-smart TVs, they're computers too. They need to compute which channel that you're on. When you press to go on the guide to see what's next, that's all. It all has to be computed and programmed by somebody. So we move on to another kind of computer now, and I'll be very impressed if anyone actually knows what this is. Does anyone know what this is? Can you tell me? Put it in the chat or. Oh, I accidentally skipped to the next slide, but that doesn't matter. Can anyone tell me what that is? Aha, my mistake. I didn't even have the chat open. I was on the Q&A, so I haven't been seeing everything that you've been saying, but brilliant. I've just seen it. So yeah, a few of you have got it right. It's a supercomputer. It's a data storage center. This is actually a cloud storage center. I think this is Google's. I might be wrong. Well, I'm pretty sure this is Google's cloud storage. So when you store something in the cloud, it actually gets stored on a computer in a big warehouse somewhere that looks something like this. So there's no such thing as this. So many people see it as this sort of magical concept, the cloud, but data's got to be stored somewhere. And this is just one of the places that it gets stored, on a big server like this. And it's the same with Facebook. All your pictures that you post on Facebook and things like that are all stored in a data center somewhere like this. And these can be huge, huge, huge buildings that you've never seen anything like. And this is just a giant computer, no different to what you're using now. Okay. What about this? Has anybody seen this? Can anyone tell me what this is? Has anyone seen this before? Yeah, I think Zayan's got it right. He said it's a code cracking computer. Yes, a few of you have put it already. Yeah, it's actually the Enigma machine. It was there was a really popular film called the Imitation Game with Benedict Cumberbatch, which I'm sure a few of you have seen. I know it was something that really got me into computing, and it is a machine that was used to crack the code that the Germans used every day during the Second World War. And yeah, it was invented by Alan Turing, who, whatever course you go to do at university, if it's anything to do with computing, one of the first things you'll learn will be that Alan Turing, they call him the father of computing. He invented this machine, which you can see all the dials on there. They're all different possible letters, and they had to try and figure out the code that the Germans were sending their messages in. And by using different options of letters, and you could use this, and he built this machine. It was the first mechanical computer, and it really isn't dissimilar to the computers that we use today in the way that it works. It obviously looks a lot different and is so much better, but it's pretty similar in the way that it works. And one actually interesting fact with this, have any of you heard of the term bug? I'm assuming that some of you know what a bug is, some of you that have done coding before. And if not, we call a bug is just something that's wrong with your code. When you've written some code, you think your program should do something you want it to do, anything at all, and it doesn't do as you expect, and you're not sure why, and we call it a bug. And it's actually called a bug because when they were building this machine, there was a moth stuck in one of these discs here, and they couldn't figure out why it was broken. And it wasn't until they pulled it apart and found this moth that they realized it wasn't actually something that they had done. It was just this moth, this bug that had got inside it. And I'm not sure how true that is, but that's how the story goes anyway. And someone saying in the chat that there's a code breaking headquarters in London called GCHQ. I'm pretty sure GCHQ is actually in Cheltenham. There might be, in fact, almost certainly are probably parts of it in London as well. But the main cybersecurity headquarters for the government is GCHQ. You're right, and they do code breaking and all sorts of cybersecurity to make sure that the sensitive information isn't being hacked and whatnot. Okay. What about this? Can anyone tell me what this is and how it's a computer, more importantly? Okay, no one's got any ideas for this one, but that's okay. This is actually a CCTV camera. Yeah, it's a security camera. It's a CCTV camera, And this is what we call, well, a PTZ camera. Don't worry, you don't have to remember that. It just means that it's a pan, tilt, and zoom. It means that it's a special CCTV camera that can move around and turn and follow people. And these sorts of cameras nowadays are really quite powerful computers, a lot of them. And they are powerful in the fact that they can not only record, which has been around for a good number of years, CCTV cameras that you see in the streets, but these sort of ones, because they can move, they're also programmed to move automatically, to follow people. For example, criminals, the police and the security service use things like this to automatically follow a wanted person. For example, if there is somebody they spot on a camera that's wanted for a certain thing, the cameras can automatically track that person and they can help track them down. And this takes a lot of, you've probably heard of these buzzwords, artificial intelligence or AI and machine learning, and that sort of things can be applied in computers like this as well. It's not, this is all just to demonstrate that it's not just the computer that you have at home. Okay, this next one's a little bit tougher. I'll be impressed if any of you get this. Does anyone know who this is or why they're famous? Yep, someone's put as a question instead of in the chat that this is Ada Lovelace. People have put it in the chat now as well. Yeah, this is Ada Lovelace, and Alan Turing's known as the father of computing in the 1900s, in the 1930s and 40s, until he passed away in the late 40s, early 50s, I think. It's not Mary, Queen of Scots, no. But yeah, Ada Lovelace, I suppose, is the mother of computing in that respect. Ada Lovelace is a lot older than Alan Turing. She was born in 1815 and died in 1852, I think it was. So this is well before computers were ever thought about. But she was the first person to come up with a mathematical structure that describes what we call variables, which those who are into programming, who have programmed before, will know what a variable is. And she created a machine that she didn't call a computer. She didn't know that it was a computer, but she created a machine that had this concept of variables, of storing numbers to things. And this actually, these things that she invented, really said discovered, but no, she invented, she crafted these on their own. They still, those of you who know computing will know that this is a basis of almost everything that we do in computing. So yeah, she invented loops as well. If any of you know a little bit more about programming, loops as well, she invented that concept, which is all applied in today's. So she, I suppose, in herself was a computer. And what they used to call people during that period, people who used to do maths as a job for calculating sheets for companies and accountants and things like that, they would call these people a computer. The person did the computing, which is where the term a computer comes from, I suppose. Okay, and one last one of these. Anyone know what this is? Any guesses? Guesses as to what this could be? Yeah, Umar's got it right. Oh, no, sorry, my mistake. It is a calculator. Oh, perfect. So someone said that it's Babbage's computer. It's Charles Babbage's computer. That's exactly what it is. He called it, I think, at the time, his calculating machine. This was around the time of Ada Lovelace. I think this was a little bit after she died, because Ada Lovelace used to work for Charles Babbage, and so they were both interested in the same sort of things. And this was actually the first calculator. I mean, you've got calculators here, or they fit in your pocket. You've got them on your phone, I'm sure, on your computer. But this was the first calculator. And it used this idea of loops and variables that Ada Lovelace invented to be able to mechanically, with actual moving parts, calculate sums phenomenally quicker than was ever able to do before. So, I mean, we've seen how much technology has developed in the 150 or so years since then. So that's really, really quite groundbreaking and interesting to see, I think. Anyway. Moving on to, I suppose, the crux of this presentation, which is, what is computer science? I know it's quite a high-level, abstract question, but I'd be interested to see if any of you in the chat have any ideas, or it can put into one sentence what you think computer science is, or computing in general. Computing and computer science, they are complete synonyms. Some people say one thing, some people say the other, but they both mean the same thing. Yeah. Umar's right. It's a study of computers, and moreover that it's the science of computers, yes, but it is the science of computers and the science of everything around you. Like we've covered, your phone's a computer, your TV is a computer. Everything is a computer, and computer science is the study of how these things work. Like I mentioned a bit earlier, a lot of people see it as some sort of intrinsic black box that's a bit of an enigma, a bit scary, these magic things that do things. But computer science is understanding how things work, how the phones work, how TVs work, but more than that, how things like the internet works, things that you can't touch, how all technology sort of works. So the formal definition that they used is that is used is they say it's the study of computers and of computational systems. So computers like we know, computers like we've got here, but computational systems is this sort of overarching term of phones, TVs, these CCTV cameras, even Babbage's calculator machine. They would all be computational systems. So it's a study of how they work, and computers rely solely on logic. So I say to a lot of people that are asking me, and you don't have to know everything about computers. If you're good at logic and you're good at maths, then you're almost certainly going to be pretty good at computing. That doesn't mean if you're not good at maths, you won't be good at computing. It's a definite real help. And the one thing that if you do study computing at uni, you will get asked all the time, it's not just fixing printers. Everyone will ask you to go and fix the printer and think that you're the font of all knowledge when it comes to computing. I can tell you now, that's not the case, and you're still going to be trying to sort things out on your computer and getting annoyed because things aren't working, just as everyone else does. So studying computing isn't knowing how to fix computers, it's knowing how to build them. So we say that the ICT, or what a lot of people think of as computing, which is using things like Microsoft Word or Excel, which I think a lot of them, especially my parents or my grandparents, think that that's what I do computing. But it's more than that. It's how to build these programs, how to create these things for yourself and not just use something other people have created. So of course you're here because it's in your mind that you're thinking about studying computing at uni, but there are so many options. I think if you've actually looked into that, I think those of you that are in year 13 would have probably been reached this stage already, so you probably know these bits, but those of you that are in year 12 are probably just starting to look at these sort of options, and there are so many different options that you can do, and they can get quite confusing sometimes. So I want to break this down a little bit. So you can do a BSc or an MSci or an MSc in computer science. BSc is bachelor's, MSc is master's. I'm assuming a lot of you probably already know that. A master's is usually an extra year in length, but you get a higher qualification out of it. And what you can do in most universities, if you decide to take a master's, and after the first year you think, actually, you know what, I'm going to stick to the bachelor's, you can do that. Most unis are pretty okay with you doing that. And the same the other way around as well. If you're doing a bachelor's and after a year you decide, oh yeah, you know what, I actually want to do a master's, I'm really enjoying this, most unis are going to be fine with that. But yeah, it's really good to do all them. You can also get software engineering, which is a very close form of computer science. It's a big part of computer science, but software engineering is more applied. So remember how I mentioned earlier that computer science can be quite mathematical, and it's about understanding the logic behind computers. Software engineering focuses less on the maths behind it and the theory behind it, and more on actually building programs and games and things that you've probably seen or what you expect them as computing. So computer science has a lot of software engineering in it, but it also has a bigger theoretical background than just a software engineering degree. And sometimes if for software engineering, it'll be BEng instead of BSc, which just means engineering instead of science. But they're both just as valid and both as well looked upon if you're trying to find a job afterwards. Some degrees you can also do specifically with artificial intelligence. Sometimes they're called computer science and artificial intelligence. Sometimes they're just called artificial intelligence or AI. Again, it depends on the uni, but this just has a lot of the fundamental stuff. In most unis, actually, on all three of these courses, the first year will be exactly the same. It's building up this foundation. But it has a separate, different specialization as you go further. And just like with the BSc and the Masters, if you wanted after the first year to move on, actually, I want to do an AI specialization, most unis will be okay with that. Somebody's saying in the questions, is a master's equivalent to a postgraduate degree? The answer is yes, to an extent. So you can do, from an undergraduate, which is what you'd be going into as an undergraduate, you would either be a bachelor or a master's degree. And like I said, master's is a bit further on, and it's an extra year. You can alternatively do a bachelor's first, graduate with your bachelor's, and then do a master's. And a lot of people do that, and it's just as valid. So yes, a master's is a postgraduate degree. After a master's, you could go on to, if you like, a PhD and things like that. But the key is, it's not going to make a difference in terms of how companies look at you, and it's not going to look any different on your CV if, say, you've got a master's, an undergraduate master's, or if you did a bachelor's and then a master's. It doesn't matter. Companies look at it exactly the same. Only the one reason that I chose an undergraduate master's is because with student finance and funding, you get less funding. If you do a bachelor's and graduate and then do a master's, you get less funding for your master's. Whereas if you do a master's undergraduate level from the start, then or you get the same, you get more funding for it. Umar has asked, is there going to be hardware engineering as well? Yes, that's absolutely a thing. I haven't put it on here, but like I said, there are lots of different unis doing lots of different things, but they're definitely hardware engineering. But I would say hardware engineering goes more along the sides of electronic engineering as a separate degree than computer science, but that's more personal opinion. Different universities will do different things. Someone said, what's the difference between a computer engineering and a computer science degree? Computer engineering would come under software engineering. So like I mentioned a little bit earlier on, that software engineering is less theoretical. You still have a lot of the theory to it, but it focuses more on the building the programs and actually creating stuff that you see. And the opposite to that, I suppose, is computer science and maths, which goes the other direction from the standard computer science, where the software engineering goes the more practical side. The computer science and maths will have the practical side, but it'll focus more on the theory. And some people really enjoy doing that. And I know in my university, for example, people have to do a separate research project in the maths side of things. And I know a good friend of mine really enjoys that. But the way that it's structured will depend on the university completely. But the computer science and math is a more theoretical part of computer science. And the last one I've got down here is company partnerships. This is becoming actually more and more common. I started uni 4 years ago, and since I started this has become a lot more common that companies, you'll be able to apply for a degree with a company and a university. So to give my uni as an example, they do a bachelor's degree with computer science with Vodafone. And what that means is you sign up with Vodafone, you apply in the same way as you do with everything else, and they will pay some of your student fees. They will give you some money towards your studies. You will do a placement year. We'll focus more on what placements are a little bit later on, but you'll do a placement year working for Vodafone in the middle of your degree or at some point in your degree. And like I say, they will fund part of your degree and your placement will be paid. So it avoids a job hunt. And a lot of the time, these company partnership degrees will be a guaranteed job at the end of your degree if you do well enough, or if you meet certain grade expectations. The problems, the downsides of that are, well, it's similar to its positives. The positive is that you're likely to have a job at the end of it. The negatives are sometimes they can make you sign up to have a job afterwards, even before you know what you want to do. So it's definitely worth looking at. And if there's a company near you that's offering it with a university near you, then it's definitely worth looking at. Just having a look. So the questions now before we move on to the next slide. Somebody's asked, is a computer science degree challenging? Yes. I know from personal experience that I found that among my friends who aren't on my course, of course, with the friends on my course, our workload is pretty similar. But with the friends not on my course, I find that I have more work than most others continually. I find that computing, because it's quite a practical degree with a lot of coding, it's got a lot of coursework. It also has exams at the end, absolutely, but it relies a lot on its coursework. So you can find a lot that you will have more coursework than you would than another subject would, but still have the same at the exam. So yes, it's hard, but if you're interested in it, you actually, a lot of the coursework is really quite fun if it interests you. So computing is something, if it interests you, it's great fun. If it doesn't, it can be quite challenging. And someone again said, is software engineering like learning computer languages like Python? Yes, but it's really worth pointing out here that everything is learning programming languages. For example, I do MSc computer science, and we learn lots of programming languages. So every single choice here will involve you learning and understanding lots of programming languages. Absolutely. But software engineering will just take that to a bit of a next level. It will have that as the main focus of what you can do with programming languages. Whereas the theory behind computing that I mentioned a lot of the time is a lot of how programming languages work. Things like compilers. I know some of you will understand what a compiler is or an interpreter. If you don't, that's really okay. But the background theory of computer science that wouldn't be on software engineering would be more about how compilers and interpreters work, how programming languages themselves work. But you would be learning programming regardless of what that you do. And I'll just quickly, before I move on, I will answer the other question of what jobs will software engineering get you to. All of these jobs will allow, there's no job that you can only get if you do software engineering, or you can only get if you do computer science. Take the one that interests you, because if you find a job that interests you, if you can prove that you've got a degree like this and you can prove that you're going to be good at it, that's fine. That's what companies want. It's not like you won't be able to get an artificial intelligence job if you don't do an artificial intelligence degree. That's not the case at all. When you're applying for jobs, if you've got a computing related degree and you can prove that you've got the skills to do it, you will get the job regardless. So do what you enjoy out of this list, I would say. Okay, so let's have a look at what a typical first year would look like. I'm going to go a little bit fast now because I realize I'm running a little bit behind schedule because I want to get a code demo done as well. So this just shows some of the things that you might be expected to do in your first year. Like I say, again, some unis are going to do it differently. Some things from first year will be in second and juggled around. But just to give you an idea of the sort of process that will take. So your typical first year will be how to use software tools, so how to use things like an IDE and how to program and how programming works, and you'll learn so much so quickly with that. I think the most I've learned the most quickly was my first term in university, because it's really fast, but it gets you to a really strong level pretty quickly. Robotics, you can see here, I've got a little video later on if we've got time that shows the robotics that we did in first year, and you can see here that you can get little Lego robots and they are following the line around, and so we do robotics actually, well, in my uni it was our first term. In a lot of unis it's the same. Look at artificial intelligence, that will be applied to the robots, of how the robots can decide what is good to do, what they want to do. Data structures, which this is probably the boring part of first year, but it's really important. It's understanding why, although there are millions of ways to create any different program, why some ways to create a program are better than others. And it's quite mathematical, but it's really interesting. And if you understand that, it definitely puts you at an advantage when you're going to code something else. And also a lot of first years will look at app development and object-oriented programming. App development, I'm sure you know what an app is on your phones and whatever. So a lot of first years will look into how to create a simple app on your phone. And object-oriented programming, those of you that are taking computing at A-level will know what that is. It's a style of programming. It's quite a common style of programming, especially in software engineering. It's a really common style of programming. And if you don't know about it, Universities don't expect you to know computing beforehand. It's great to have a computer science A level, but it's not expected. So don't worry if that doesn't make sense to you. No need to be scared. And then your second year, you've got things like machine learning, which is like artificial intelligence, just a bit more advanced, and how to make computers learn from their mistakes. It's how to make computers learn from their mistakes and improve what they do because of that. Game development. I've got a little video at the end of this that I will show of a game that a friend of mine created in second year, and it was really good fun. And a lot of that is done. Theory of programming. This is in second year where you start to separate the degrees in terms of the module you do. So if you did a straight computer science degree, you'd have a lot of theory of programming, of understanding why programming works, what programming does. And perhaps if you're doing software engineering, perhaps that wouldn't be the case. Functional programming, which I would be very surprised if any of you have heard of, let alone done at the moment, which is a different style of programming. It's interesting. If you can search afterwards, I should have got a picture really of functional programming, and you'll see the code. If you can code already, the code looks completely different, but it's got its uses. It's used in banking and things like that. Professional practice and ethics, understanding what's good, what's bad, what laws surround it. And also software security, which is the one I think that a lot of people really look forward to when they come to computing. It's ethical hacking. So I know in my uni, for example, and most unis do it very similar. They give you a network or a system. They give it to you and say, right, try and hack this. And your assignments are to hack this. And they're real life assignments and real life hacking, just in a secure environment. And it's really, actually really interesting and fascinating. And also HCI, which is human computer interaction, which is how humans behave and interact with different computers. Okay. So let's have a look at this video quickly. I won't play anywhere near all of it because we are a bit short of time. So this, I'm going to mute it. Okay, that's not wanting to play. I will go back to that at the end if we've got time. But you can see here a friend, for his assignment, he made a Goat Invaders game, which if you've seen Space Invaders, it's a little bit like that. You can see at the bottom, he's got his spaceship and it fires lasers and kills the goats as the goats move down. And he managed to make this in his second year at uni. And that's a really achievable thing to do. Okay. I am seeing some questions coming in, but I'm going to leave a lot of these questions till the end now, but I will answer them, so don't worry. In your final year, this is quite far away for most of you, so I won't spend too long on this. You will, of course, have your dissertation. If you're doing a master's, this will be 60 credits, which will be 50% of your whole year. And if you're doing a bachelor's, this will be 40 credits, or a third of your whole year. You will do some complex programming. You will, and I should probably mention that in final year, it's a lot less rigid. So in the first and second years, you've got a lot of compulsory modules, whereas in final year, there are usually very few, if any, compulsory modules. So yeah, you'll do some complex programming if you want to. You'll do some advanced robotics and computer vision, so how to make robots and things see, and how CCTV cameras can capture faces, like we mentioned earlier. That sort of thing comes under computer vision. Really deep machine learning or neural networks, which I put that term neural networks in there because I'm sure a lot of you have heard of it. If you don't know what it is, it's an advanced topic. It's quite a buzzword that you see everywhere. We use neural networks. A lot of companies use that, and you'll learn about what they are and how they work in your final year, maybe even in your second year a little bit. And then you'll move on to deeper security. So I know in my university, the final year security module, which I don't take, is hacking a real life game off Steam. They've got to download a game on Steam, and the assignment is to make a cheat for this game. So that I know a lot of people are finding that really fun. And also teaching in schools is quite common as well. I know I did it going into schools, teaching. We did 10 weeks, 1 day a week, going in and teaching people in primary school, secondary school. A lot of unis do similar things to that. And if you're in a master's course, then you will have 2 final years. So there will be a list of maybe 12 modules, say, to take, and a normal bachelor student would take 3 or 4 of these over their final year, whereas the master students would take 4 or 5 in their first final year, so their penultimate year, and then more in their final year. So the masters have 2 final years as opposed to the 1. Okay, I did say that I'd mention the industrial placement and also study abroad. I did my placement. That's what that picture is. That was my desk. You can see probably some CCTV cameras there. That's why I'm interested in that. I was working on CCTV cameras on my placement. Yeah, well, I accidentally pressed it twice then, but it's okay. Industrial placement, it means you can work in a company before graduating. You get paid for it, you get a salary for it, and you get student finance as well. And it's really good. And I was 50-50 about whether to do it. I got offered the placement and I decided, right, you know what, I'm going to take it. And it's the best thing I've done. I took a year out of uni. Yes, it extends your course by a year, but it gives you so many skills that just computing, that uni just doesn't teach you, because in uni you'll do a lot of small projects or projects with a smallish team. Whereas actually working in industry is the first time you'll see code that's been written by hundreds of people being maintained for years and years and years. And this is really important, understanding how these processes work in industry. So I couldn't recommend it highly enough. And of course, if you impress in your placement, you will often secure a job. They'll often say, right, go back for your final year, come back, and you've got a job here secured, which is great because some companies will even pay for your final year to keep you. But also in your final year, it's very hard to find time to keep applying for jobs while you're doing your dissertation and all your modules. So if you can grab that first, brilliant. Also got study abroad, which, I mean, does what it says on the tin. Again, it adds a year to your course. You go to partner unis throughout Europe or the world. It, like I say, it depends on the uni, and different unis are different partner unis. You can go over there, study their computer science. Different countries do have different structures of computer science degrees. I'm not going to go into any detail about what they are because I don't know specifically, but different countries have different approaches to computing. And yeah, and you can also even learn a new language. And somebody said, which I think is worth answering now, can you have a quite good salary even if you do a part-time job? Absolutely, you can. As a placement, I would recommend doing it full-time, but again, that it really depends on your situation. But you can earn quite a good salary if you did a part-time job as a placement or postgraduate. It really depends on what you want to do. Yeah, so I'm going to move on now. And it says, I can't code, which is firstly what a lot of people say. It's what I think a lot of the time. Even now when I'm doing code, I'm like, I'll do stuff, I'll get stuck on something and be like, oh gosh, can I even code? I don't have a clue how to do it. Yeah, but nobody can. That's the point. The beauty of code is the beauty of coding and computer science, which I think you'll spot very quickly if you did this at uni, is using what other people have built or already coded and improving it to make it your own and adding new functionality. It's very, very rarely that you'll have to code something from scratch all for yourself. The beauty and the skill in computing is to be able to understand what other people have made and build your own things from it. And coding is just applying mathematics. I say to a lot of people who just don't understand what computer science is, that it's just applying maths. And like I mentioned at the beginning, if you've got a good grasp of maths, you'll have a good grasp of coding, but it's not all coding. As I say, there's a lot of understanding of the theory behind it as well. And if your focus is just to do coding, then a software engineering style degree is probably better, although you can't avoid you can't avoid that section of it. It says, let's try here. We will do a quick code demo in a minute if we've got the time, but I'm not sure we can afford it. So I'm just going to move on for now. Types of careers you can get in the future. Data science is the first one. And I noticed someone in the chat asked what data science is. And very briefly, data science is understanding or being able to look at huge amounts of data and find trends in it. So a common example would be adverts on Facebook. You probably see that if you go onto a website looking to buy a new coat at some point or something like that, and you then go onto Facebook later on that day, you'll see adverts for all different coats you can buy. that's data science. It's people or systems in somewhere that are analyzing your traffic, your traffic or what you're doing on the computer and finding a trend in that and saying, oh, he's looked at lots of coats, let's suggest coats to buy. But it's also used for things like diagnosing cancer and things like that. I won't spend too much time on that because, like I said, I know it's a short time. Robotics as well. People can get good jobs in robotics. Think of warehouses. Now you probably know lots of the Amazon use robots now in a lot of their warehouses. So there's no people, that there are fewer people picking the items off the shelves and giving it. They have robots running around grabbing items off the shelves. So that's all part of computer science. Finance as well. There's a lot of money in finance. If your goal is solely to get a good salary and you're not worried about working 16-hour days, six days a week for the rest of your life, then finance is definitely the sector for you. There's a lot of money in it, but it's very high pressure, but that's all computer science, and it's all data science as well as analyzing patterns in finance. Games development, which I'm sure, which I think it's probably fair to say that a lot of you are probably quite interested in, which is self-explanatory. And this I wanted to show is what the US government envision by 2022 will be all of the jobs in STEM, or in science, technology, engineering and maths. So they think, although this is for the US, I couldn't find a nice graph for the UK, but it's very similar. The trend is pretty similar, that they think by 2022, 60% of all jobs in science will be in computing. And they actually think that 70% of new jobs in science will be in computing. So there's a heck of a lot. So is computing right for me? What I'd say is, if you're interested in it, if what I've said is, if you've been watching and thinking, oh, that sounds interesting, or wow, I didn't realize that, that's what you need to decide computing's right for you. You don't need to be able to code, because it's worth pointing out that even if you're doing A-level computing and you've done it in your spare time, I can almost guarantee that within the first term, the first 10, 12 weeks of uni, you'll finish that thinking, and you'll realize yourself, oh God, I really didn't know computing at all before that. Unis will start from scratch because computing's quite new. Unis don't expect you to have any computing history, so you will learn it quickly. If you're good at maths, if you enjoy maths, and if what you're saying is something interesting, then computing is right for you. Okay, so we've got 15 minutes left. I am going to do a quick code demonstration just to show you how quickly you can get something that looks really good, and then we'll have about 10 minutes of questions then, and I'll read through all the questions then. So I'm going to share my other screen. New share. Screen one. Okay, and you should be able to see my code here, which I've not got anything in it at the moment, but if you can't see it, let me know, because of course I'll have to change it. Anyway, so it doesn't matter if you understand all of this. I don't expect you to. It's just showing how you can create something pretty quickly. So this is to create a game. I'm going to create a width and a height. Like I said, I'm going to go through this quite quickly, so it doesn't matter if you understand why, or even if you've not seen Python before or coding, it doesn't matter. This is just to show that you can create something pretty cool relatively quickly. And what this will do, even just these 4 lines of code, if I run them, it's just creating a game window here. So now we want to create an actual game. We want to make it do something. So to do that, I define a function called draw, and in that I can say screen.fill, and then I can say blue, and then here if I run it, what's going to happen? I'm going to have a blue background. Again, it doesn't matter if this doesn't make that much sense to you. Again, it's just to demonstrate how quickly that you can create something which is pretty neat and pretty cool. Okay, so now I have a character on there. I'm going to call my character Boris, and I'm going to say he's an actor. An actor in computing is the word we use for a character on a screen. And I'm going to have him as an alien. You might be able to see I've got a picture of an alien stored. So I've created a character called Alien. I am going to draw him on the screen, boris.draw. And now if I run that, I am going to get nothing at all. which is a little bit strange. I'm not 100% sure why. Boris equals actor. I'm not sure why that is. And that's what you'll find as well with computing. You will get into lots of ruts like this, that it just looks all right, but it's just not working. There we go. I don't know why what I've done differently. You can probably spot it instead of me. But now I've got this little character on here, and I am going to add one more thing nice and quickly. So I'm going to create another function. So on, I think it was on mouse move, and the position I move the mouse to. So this is every time the mouse is moved, I'm going to change the angle of Boris to pause. So every time I move the mouse to a certain position, Boris is going to point to that position. And you can see now, as I move the mouse, Boris will spin around. Okay, and we're going to make one more thing into it. It's going to look, again, a little bit different. I'm going to copy and paste this function in just for time because I wrote it earlier. So this is an update function. So this just means it happens constantly. So this is happening all the time. I trust that you can see this, by the way. Please tell me in the chat if it's too small to read. This happens constantly. So what I'm saying is all the time, I'm checking. If you're pressing the left arrow key, then you move Boris along the x-axis, minus. If it's the right arrow key, you put him along the x-axis up. You put him positive along the x-axis. If you press up, you're moving negatively across the y-axis. Basically, the y-axis is upside down. It doesn't matter why that is. We don't have time to explain that really, but it's in computing a lot of the time that is the case. But what do we think will happen now? Like I said, you don't have to understand exactly what this code is. But if I run this, what's going to happen now? So firstly, Boris moves and I move the mouse like that. But if anyone could, I didn't press save. That's why that didn't do anything differently. Now I press save, that might make a difference. There we go. I can now move Boris around with the arrow keys. And as I move the mouse, he spins, and I'm using the arrow keys to move him around. See, and you can see that in relatively few lines of code, we can make that work. And I can change it really easily. Instead of the alien, I can have a spaceship, which does exactly the same thing. So yeah, that's what I wanted to demonstrate with that. So I'm going to go back to my presentation now, which you should still be able to see. Let me know if you can't. I will play these videos in a little bit, but I want to focus first on the questions, just to make sure we've got time for that. If we run out of questions, I'll show you some of the cool videos. So I'm going to go through the ones that have already been asked, I haven't answered. Can you do computer science uni without it? We've done that one. Is it tertiary storage? Lovely, we've done. Is the internet in cables underground or is it wireless? That's a good question, actually. The internet is actually just a huge set of cables underground. You can find a map somewhere on Wikipedia, a rough map of all the cables that go across the Atlantic everywhere. So every time you go onto a website or press something on the internet, it will send electricity down huge cables. If you go to a website that's in Australia, that's hosted in Australia, the server's in Australia, you will be sending data across wires all the way to Australia and back. And what you will notice actually is if you go on a website that's in the UK, it will load quicker than a website in Australia because it can't go to you without having traveled to Australia, which is obviously very far away. So yeah. Is a master's equivalent to a postgraduate degree? I've answered that, I think. Difference between computer engineering and computer science degree, I think I've answered that. Is it going to be hardware engineering? I've answered that. Is computer science degree challenging? I've answered that. Did I always want you to study computer science? Yes. I always knew it was something I was interested in. So I did GCSE ICT. Computing GCSE wasn't a thing even 6 years ago when I did it, 7 years ago. So yeah, I knew I was interested in it. So at A-level, I went to a different school to do computer science because I wasn't sure whether it was interesting for me, whether I'd actually like it. I was nervous about not doing a computer A-level and then doing it at university and hating it. I was scared of that happening. But I loved it at A-level and took it, and I really learned from that actually what I did at computing A-level wasn't that important in terms of I learned all of that and more very quickly at uni. And I think that, like I keep saying, if you've got an idea of maths and you enjoy maths, or what I'm saying to you is just interesting and it's making you question, oh, right, I didn't know how that worked, or it's even making you question, oh, how does something else work? If that's the case, then absolutely you should study computer science. Have I created a website or an app before? I've actually not created an app. I stay more on the theoretical side of things, like I've mentioned, and what we call back-end programming. So how things work that you don't actually see and play with. Remember the CCTV cameras, so how that sort of works, that any user using them. But I've created a website. I do work for a charity, and I look after and maintain their website. And although it's the only website design I've ever done, because of the other computing stuff I know already, it's actually quite easy to apply what I know to that, and to be able to transfer the skills from one area of computer science, which is CCTV cameras, like the example that I'm giving, to creating a website for a charity. Although they're different, the theory and the logic behind it is really, really similar. Okay, so I've done that one. Would you use some coding in aerospace or mechanical engineering? I hear that sometimes you do, but I'm not sure. You absolutely do. In all engineering, okay, I don't want to stroke it all the same brush, but in most engineering, I've got a lot of friends that do engineering as well. In almost all engineering, there is a substantial amount of coding. Aerospace engineering, electronical engineering, mechanical engineering. If you do any of those degrees, you'll have an idea, a good idea about what code is and what coding is. You absolutely will. But we always have a joke as the computer scientists with other engineers that they don't actually know how to code, because they learn how to code for what they need. That they learn, okay, we need to create this, so that's how I'm going to code it. Whereas a computer scientist would learn how code works in general. So a computer scientist could find a new problem, and what they've learned to be, what computer scientists would be able to do is figure out how to tackle that problem, even if it's something they haven't done before. Whereas an engineer would look at a problem and know, okay, for this kind of problem, this is how I go about coding something like that. That's the distinction. That's why we joke that engineers can't really code, although they absolutely can. Could you have quite a good salary even if you were part-time? I've done that. If you were to study abroad, would you study computing in that language or in English? It would be in English, because it's usually with partner universities that have a reciprocal agreement, so people go both ways each year. I don't know if universities let you go to a uni that you decide yourself. I'm not the one to ask about that. It'd be the unis themselves. But any uni that has a partnership, it would be studying in English. And most universities let me rephrase that, a lot of universities in Europe, especially in the Western world, even if it's not on an English-speaking country, will run a lot of English language courses, especially in science and engineering, because English is the language of engineering. And I'm actually applying at the moment, because I'm in my final year, to graduate jobs all over Europe. And you'll find that most computing jobs in Europe, the language to go to is English. Like the working language that they do is English anyway. So you can probably get a job in most countries in Europe without speaking anything other than English. What's data science? I touched on that, I think. Why do people say Python is used for data science? That's a good question. And that it's because data science, more than a lot of other areas of computer science actually, is applying maths formulas, think of things like probability and things like that you do in your maths lessons. Data science is the application of maths specifically. And I'm sure that you've seen pictures of code, not in Python, in other languages, for example, C or C++, and it can look very confusing very quickly and get very big very quickly. But what Python is good at is it's easy to read. If for somebody who can't code in Python, Python's easy to look at and know what it's doing. So that's why that's used. You can comparatively easily write down or complex maths formula and deal with big amounts of data in Python than you could in C or C++ or Java or any other language. But it's crucial to understand that theoretically, you can do anything in any language, but there are some which are just nicer to do, which is why different languages are chosen for different things. What application is this? I'm assuming that was when I was writing the code demo. that was the text editor I used was called Atom, which was just a text editor. But to write the games, it's a thing called Pygame, Pygame. It's writing games in Python. And this was Pygame 0, which is like an even simpler version that allows you to create games so quickly, like I did. So yeah, it's completely free. I think you can download it off their website if you wanted to. I'm not paid by them, it's just, so don't worry about that. But yeah, it's good. I would recommend it. Hi Sam, do universities teach specific languages in their computing courses for the practical elements, or do students get to pick what languages they use for writing programs and what environments they use? Yes and no. Universities will usually teach one language from the start. For example, in my first year, they taught Java, which is what they use to explain computing, get everyone to an understanding of computing. The environments they use in the same respect, the universities in your first term will teach you how to use a specific environment or a specific IDE. The university will teach you how to use a specific one, but they will not dictate you have to use this environment. For example, we learned an IDE, an environment called Eclipse. I used it for about a week. I didn't like it, so I used another one called IntelliJ for my Java, which I've loved. I still use it today. So although the unis will teach you one thing, if you're unsure, stick with what the unis are teaching you, because if you need help, you've got help from the lecturers to do it. But if you're confident with something else, no one's going to stop you. Like I say, your first sort of term or something will be learning one language. And then for most other modules, although you'll have, I don't know, a C module or a Python module later on, perhaps, if you want to learn those languages, for most modules, they will say, use whatever language you like, because it's showing that if you can show that you can do the computing, that's the important thing. Thank you for the great lesson. Now I'm more sure of what to do. That's very kind of you. I'm glad that you've enjoyed it. Do you recommend doing a foreign language and computer science for A levels and uni? I'm not aware that was a dual thing at all, but absolutely, like I said, if you're going to Europe or the Western world, that you don't need a foreign language. But I've got, from my personal opinion, is there is never a wrong time to learn a new language, and I personally think that if you have another language on your CV, that's going to enhance every job application, regardless of anything. So yeah, I would say that's a great idea. I've used JavaScript and C and C++. And Python are really important languages. Have you learned them? I've not learned JavaScript. I've learned C, C++, and Python. Like I say, different languages are used for different things. Python's really important for data science. C and C++ are really important for what we call low-level programming, which is on CCTV cameras and embedded systems and things that you don't touch as such. So, for example, your operating system, like Windows 10 itself, will probably be programmed in C or C++. JavaScript is used for web design. Like I say, I haven't done a great deal of web design, so I've only done a teeny bit of JavaScript. But this is the key. Once you understand, as a computer scientist, once you understand how these things work, you can apply your knowledge to different things. So, like I said, I do a bit of web development and I can apply what I've learned. And that's the difference between other sorts of engineering and computer science and software engineering, I think. Someone said, thank you for the amazing lesson. Thank you. That's very complimentary. I really appreciate it. Do you have to study A-level computing to do it in the future? I can't stress enough, no. A lot of unis now are starting to require maths as an A-level. It never used to be the case, and it's not the case everywhere. But computing, because it's still quite new, a lot of schools still don't teach computing at all. You won't have to have an A-level computing. Like I said, I did it. I went to another school to do it because I was really nervous that I would take it, not like it, and then not know what to do with myself. But looking back on what I've learned from doing that is, yeah, I'm glad I did it, so I had an extra bit of experience in computing. But everything I learned in my A-levels, I covered so quickly in my first term in uni. And if you think you know programming after your A-levels, a term in uni, you'll realize how much you didn't actually know. And if you went back to do your A-levels even a year later after your first year of uni, you'd find your A-level computing really easy. So no, you don't have to do A-level computing. I would say if you enjoy maths, you enjoy that sort of side of things, then that's the key. So yeah, we have 1 more minute. and nobody's asking any more questions. So I'm going to play this video because it's 47 seconds long. And this is showing the robotics module in my university that we did in our very first term at uni, where you can see we've got a little Lego robot. We got to create this, and it got to follow the line. And this was like a mock-up warehouse. And yeah, this, like I said, this is in our first term of uni. So we learned how to do this really quickly, and it was a big team project, and we really, really enjoyed that. So that's all we've got time for. We're just about out of time. Yeah, if you've got any more questions, I'm free for another few minutes, so please do ask away. But other than that, I thank you all. Yeah, and hope some of you take the time to do computing in future or at university. Thanks a lot. Perfect.